USA, which is in San Jose. If you are not an OWASP member, please go and register. We're going to use the honor system, but we are expecting this to be for OWASP members. The first link, if you're typing it in on your phone, is shorter, but you have to trust that I'm not trying to send you somewhere malicious. If you're a paranoid security person, which a lot of you are, we have the second full-length link that you can type. Well, you're going to get to the PHP either way, man, so I can't help you there. So I'll give everyone 10 seconds to either take a picture of this or start typing. And then we're going to move on to the next slide. All right, that was 10. So the schedule tonight, we have Kelley Robinson from Twilio. She's up first talking about analyzing pwned passwords with Apache Spark. We have Eric Fay up next from Hulu. He's going to be talking about efforts in scaling application security programs. And then last, but certainly not least, we have Segment's own David Scribonia here to talk about usable security tooling, creating accessible security testing with Zap. I'd also like to thank our monetary sponsors of the Bay Area OWASP chapter. Without them, doing stuff like this wouldn't be possible. If you work for an organization that thinks OWASP is great, you can donate. I accept cash, Bitcoin, and IOUs in the form of Caesar's Palace chips for anybody else that is going out to DEF CON. We also have to thank our sponsors that let all of you security people into their offices for these meetups. So here are the list of people that have, or companies, I guess they're people too, right? That have sponsored recent OWASP meetups. And you also have to thank Segment for employing me and hosting tonight's meetup. So if you could please clap, we deserve it. So if you're not familiar with Segment, basically the one-sentence version is we connect stuff to other stuff. And that stuff on the top here, that can be information that you're trying to send from your mobile clients, your web clients, or other cloud services. It's going to go into this blue box called Segment, and then it's going to pop out on the other end in other systems that you might want to use that data. If that sounds like an interesting thing to work on, we and every other company in the Bay Area are hiring people, and we're specifically looking for cert people, cloud-sec/infrastructure people, and pretty much any other engineering job that a company might need. So check out our jobs page, and if there isn't something on there, talk to one of our recruiters afterwards. There's probably other stuff that's hidden from you. So I was also bribed with a Segment hoodie by somebody from our marketing team to let them talk for 2 slides. And they said it's going to be 2 minutes, so I'm going to start a timer. And if they're not done in 2 minutes, I'm going to kick them off. So your time's already started.
Hey. Note to self, security presentations are to the letter. Okay, so my name's Joseph. I'm from our event marketing team. I just wanted to say welcome to Segment. I wanted to let you know that we are hosting an event on September 20th called Synapse. It's our annual user conference. Our very own VP of Security, Colleen, will be giving a talk there. So there's going to be lots of really cool people, lots of really cool content that you'll be interested in. You can see everything about the event right here. Just wanted to let you know that prices do go up August 1st, so feel free to take advantage of our $299 special pricing, and we also have other discounts for people traveling outside of San Francisco, underrepresented groups, and anyone who has come to the event before, our alumni groups. And just because I think this is badass, like these are all the cool people that are coming to speak at our event. So we're really bringing together a lot of thought leaders around engineering and product to come and talk at our event. So we'd love to see you there. And if you have any questions, feel free to reach out to anyone with a Segment hoodie. He is not getting one after this. That's not. I'm kidding. You'll get one.
Awesome. Thanks. All right. So I'm going to pass around pieces of paper and pens. If you're interested in the raffle, just put your name on there and pass it that way. We'll have a box to collect them. And the winner must be present, so you have to stay until all 3 presentations are done. Not that you would want to leave anyway. All right, so first up is Kelley Robinson. So I see her. She is approaching.
Good. Sweet. Welcome, everybody. Thank you for having me. My name is Kelley. So I've spent most of my career doing data engineering and working with data. My last job, I was doing data engineering at an advertising technology company, which is not terribly exciting. But we started using Spark, which is a data processing library, back in around 2015, when it was like pre-1.0 versions. And Spark is a data processing library that's only been around in GA for maybe 3 or 4 years, but it's something that people are using a lot of today to do data processing. And so it's been really interesting to see the project grow and evolve since then. Lately, I work at Twilio. You've already heard us mention we're hosting the next OWASP meetup. Please come to that one. And I've been working more with security and identity and authentication. And this talk combines all of those things. So we're going to be looking at own passwords through by looking at Apache Spark and how you can analyze those with those tools. So just kind of want to get a feel of the room. Who here works on a security team? Okay, who here is just like kind of interested in security? And who here can like writes code in any part of their job? Okay, cool. So there's a good mix of people in the room. The code in this presentation is relatively minimal. And I think one of the cool things about Apache Spark is that it allows you to do analysis without having to know really a ton of stuff. You can use tools including things like SQL and Python and some of the languages that are more introductory level for people that might not be programming every day. So Twilio, if you are not familiar, is a communications company that allows developers to add communications into your applications with APIs for things like voice, video, SMS, and authentication. So authentication, you say. Twilio actually owns Authy, which not everybody knows. Twilio acquired Authy a few years ago, and I spend my day working on the Authy team on our account security APIs for things like phone verification and 2-factor authentication, adding those into your applications. We have APIs for that kind of stuff. And I also spend a lot of time just in general thinking about securing online identities. And passwords have been the biggest way that we have done that in the last 30 years or so. We're starting to see some shift away from people only using passwords for authentication, moving away to other authentication forms that don't have to do with a string of characters that you memorize. But it's going to be a long time before we completely move away from that. So I think it's pretty interesting to look at passwords as we know them today. A little bit about what we're going to cover tonight. Spark, just where the project started and what's doing now, the state of passwords in the ecosystem. I'm going to do a little live demo of what some of the stuff that you can do with Spark, and then we'll wrap up by talking about big data and security. Who here has used Apache Spark before? All right, there's like 3 of you. Excellent. So you can call me out if anything I say is wrong. But that also makes me the expert in this room, so you're welcome. Apache Spark markets itself. It's a fast, unified analytics engine for big data and distributed data processing. It also does a lot of stuff with machine learning, or at least likes to market the fact that it does. It provides a functional interface for dealing with distributed data and big data. And when I say big data, I'm talking like terabyte scale. This is stuff that you can't fit on a single machine. And Apache Spark aims to solve the problem of working with data that is too big to run a Python script or fit in a single data query that you might run on top of a Postgres instance or something like that. When I was doing this in my last company, we were processing, terabytes of data that were coming in every hour. Ad tech has a lot of data. For those of you that have been working on GDPR, you would know that because all of these cookies are being dropped on you every single instance of the day on the internet. So ad tech has a lot of the data, and so we needed something that would do that kind of large-scale processing, and Spark was the tool that we used for that because Spark is built on top of Hadoop, which is another data processing library, but Spark is about 100 times faster for processing data. So a lot of companies that were using Hadoop previously have moved over to Spark because it actually saves them a lot of money in terms of compute resources. What I'll show you today probably could be run on your local machine. I'm going to be running it on my local machine, but that's for the purpose of illustration. If you only have data that can fit on your local machine, you probably don't need Spark. I just want to preface it with that. Don't use tools that are too big for the job. So the Apache Spark ecosystem, one of the benefits of using a tool like Spark is that it comes with a lot of interpreters for working with different languages. That's Scala, Java, R, and Python are some of the big ones that it has. But it also has capabilities, and it's really been promoting its capabilities for things like streaming data and machine learning. So if you're doing any kind of log analysis, whether it's batch processing to dig into your data to find out some kind of anomaly, or if you want to do more live updates in terms of like logging data, anomaly detection, could be useful for a lot of security teams that are trying to detect anything that's suspicious in your systems. Spark could be a tool for doing that because it has this streaming interface. It's not quite live. It's basically small batches is how the streaming API works, but it comes out to be something that's pretty fast. And so also I mentioned that Spark does some stuff with machine learning, but that's kind of on top of the rest of the data engineering stuff that Spark is really the core of it. And as my friend Ryan likes to say, machine learning is just like the carrot that you dangle in front of engineers to get them to do the data engineering. So it's a good thing that the platform supports both because you're already in the same ecosystem, you already know the same tools, and that's something that you can use to then do the regression analysis when you need to get to that point. So there are two major abstractions for processing data in Spark, and these are basically different types of containers that have slightly different optimizations built into them for working with different types of data. And so we started with RDDs, which is the resilient distributed data set, and those aren't going away, but data frames are much faster to work with if you're working with structured data, and so people are moving towards using data frames more now, and those came about those were really GA maybe like a year or two ago, and so people are starting to migrate code more over to data frames, and that's what we're going to be looking at today. If you want to look at RDDs, these work with, like I mentioned, unstructured data, and so if you want really low-level control, you can see here how you would work with an RDD in terms of doing a map reduce. This is a data talk, and so there has to be a word count example somewhere in here. But this is an example of how you would work with something in an RDD. It really provides that fine-grained tune control, but they're pretty slow, and so people have been moving away from them. But if you have unstructured data, this is going to be the way to go to do your analysis. However, data frames work really well with structured or semi-structured data, and because you effectively have to provide a schema for working with data frames, they are much faster. The engine has been able to optimize the data structures underneath to know what types of data you're working with, and so that you can query and manipulate the data much faster. Data frames are very similar to something like data frames and pandas, like Python pandas or R, if you've ever worked with those. It's a very similar interface. And we'll be looking at this untyped API, but just know that there's also a more strongly typed API if you're working with a language like Scala or Java that supports that in their ecosystem. One of the big disadvantages early on was that Python was just so much slower for working with Spark than Scala was. Spark is written in Scala under the hood, which is a strongly typed programming language, and so they optimized the Scala API first before they thought about other languages. But as you can see, when the data frame API came out, they optimized it across the board because of the way they wrote the optimization engine. They all transpile down to the same type of code so that the execution layer is happening in the same way. And so it doesn't matter what language you're using on top of this now. If you're working with data frames, the speed that you get is going to be the same. So that's enough about data. Let's talk about passwords. And so password reuse is a problem. I think people in this community are aware of that people reuse passwords, they reuse credentials across sites. And this is a problem because hackers like this guy, and you know he's legit because he got the word hack to appear on top of all the encrypted mess. And the beanie, like it's just, Google stock pictures of hackers, and my coworker Phil to thank for that. It is hilarious what people think hackers look like. I don't know. We should have somebody like just come into this room and take stock photos and nobody would believe it. But anyway, people use this and they do it for credential stuffing so that they can take your credentials and go buy expensive Apple products or steal your Bitcoin or whatever they want to do with it. But this is a problem because people are reusing really, really familiar passwords all over the internet. And those passwords are being made available with all of the data breaches that we've seen recently. And so you might hope that nobody does this. Nobody is writing their password on a sticky note that's 1, 2, 3, 4, 5, 6. But of course, people do. Keynote just crashed. So we'll restart that. Yeah, is somebody hacking me right now? Oh yeah, I did put my password on the slide, so I guess that's shucks. Should have known better. I mean, but this password has been seen over 22 million times. So this is according to the site Have I Been Owned, which is a project from security researcher Troy Hunt. This is the wrong thing now. This is the one that I want. There we go. Thank you for bearing with me. I did just update that slide, which is convenient because Troy Hunt just added a bunch more data to this site. So if you go back to it in like the last week, how many people have been to this site, Have I Been Owned? Okay, if you haven't been there, check it out. It's haveibeenpwned.com with a P. And you basically can put in your email or put in a password and you can get information about whether that email and password has been seen in a data breach. And if you have had that password seen in a data breach and you're using that other places, probably go change that password. So it's a good service that he provides that we as developers can make use of in the tools that we build to make sure that people aren't using breached passwords as their credentials for our accounts. So this password is the most common password that's been owned. It's been seen over 22 million times. And so this is obviously not good. This is a very simple password that is very obvious. And so it's the first thing that people are going to try if they try to hack your account. And so maybe you don't care if your pizza account gets hacked, but you know, like if you have this for your Bitcoin account, you're probably going to have a bad time. But this data is available via the API, via this website, and he also provides the data via a download that you can do that's like that's like 23 gigs of data. It's probably bigger now. I haven't updated the data set that I'm going to be working with today, but it's a lot of data that we can work with, and that's what we're going to be using to show off Apache Spark. So I actually meant to quit the program that time because we're going to switch over. So I'm going to be using a program called Zeppelin to show this off. Zeppelin is a notebook-style program that has a built-in Spark interpreter. It's pretty similar to something like Jupyter Notebooks, if you've ever seen those before. And so this basically has a built-in Spark interpreter so that I can write Spark from scratch in a nice interface for working with you. And so I went ahead and imported some of the functions. And so then what I'm going to do next is I need to have the passwords to work with. And so I'm going to pull these from my local machine. And Spark has built-in functions for reading CSVs. I have all of these stored in multiple CSV files. So I'm going to do a glob match there to make sure that I have all of them. And then let's see how many we have. About 680,000. So I truncated the data size so it would be easy to work with on my local machine. This is the size of the data that we're going to be working with. And so one of the other things that we can look at is the shape of this data. And so Spark conveniently provides a schema function that allows us to see what the data looks like. I know that there's 3 columns in this data, and so this is close to what we want. But we want to give a little bit more structure to what this data looks like. And so I want to tell it that we have a header, and so that it can go ahead and read that. And now we see what the columns are, which is pretty cool. And this is some of the built-in functionality that Spark provides for working with this kind of stuff. But the one other thing that I want to do is make sure that that count field is interpreted as a integer because we want to be able to sort by it. And so if we did the same thing, but we want to infer the schema, and that's going to be able to tell us that the count is an integer field. It does that and does the inference by doing a sampling of the data so that we can see what the data looks like. And if it sees that most of the fields that it's looking at are integers, it's going to assume that a whole column is an integer. And you can tune the sampling based on your preferences for your data that you're going to be working with. But already I think this is pretty powerful because we don't all know what our data looks like, or if we have an idea of what our data looks like, Spark can be a really useful tool for getting an idea of what kind of data is coming through our system. If all of a sudden you're seeing a lot more JSON fields or CSV columns that you weren't expecting, Spark can tell you that kind of stuff. And that can be a really powerful tool for inspecting the logs that you have coming through your system. So now that we have that data and we have the data in the format that we want, we can go ahead and show some of the things. And so we want to select the columns that we care about. And so I only care about the password and the count column, and so we'll go ahead and do a select. We're working with a SQL-like syntax on this data frame right now, and I'll show you how we can write raw SQL on this in a little bit. We want to order this, and this is going to be by the descending count. And then we can go ahead and display this data. And so this is the most common passwords of Troy Hunt's site. As you can see, 1, 2, 3, 4, 5, 6. A lot of very obvious passwords, all ones, QWERTY, I love you, oh, that's nice. Dragons in there, I wonder if that's influenced by Game of Thrones. And why is monkey in there, I don't know. But there's some interesting things that we can learn about this. And you know, people like think that they're getting creative here, like 1, Q, 2, like everybody's doing the same kind of creative stuff with their passwords. And we're not actually that creative when it comes to doing this kind of stuff. But one of the other things that I want to look at with this data is what the most common lengths of passwords are. And so I can do that by adding a column to my passwords data. And so I'll go ahead and do that, call it the length. We have a built-in length function that I imported earlier. And so we'll go ahead and transform that. How I can type and talk. It's practice. Yeah. So what we're going to be doing is creating and replacing a temp view here that has, we're going to call this a passwords view. And this is what we're going to need to do in order to run SQL on top of this table that we're creating. And so once we do that, we can create this view. And then instead of using this PySpark interpreter, I'm going to change this to a SQL interpreter. And then I can write raw SQL. And this is exactly like you would have in your SQL, whatever interpreter you were using outside of this. And so you can select this from our passwords table. And then we're going to group by and order by our length in order to see the, see, now you mentioned it and you messed me up. Need a comma there. So we can group by and order by our length. And this is going to display the most common password lengths in order so that we can use some of these visualizations as Zeppelin provides. And so this is a feature of Zeppelin that I really like that provides these kind of built-in visualizations. Scatter plots, you can imagine how those would be nice. Line charts, I don't know who uses pie charts, but I think this bar chart provides some really interesting stuff for us. This is the most common passwords, and as you might have expected, it's 6 and 8 characters are kind of grouped in the middle there, and I think that makes sense because that's where a lot of the common password minimum requirements are, and so people are not going to go above and beyond that unless they're security-minded folks like the people in this room. And so the majority of people that have to put in a password, they say it has to be 6 characters. They put in a 6-character password, and that's why 1, 2, 3, 4, 5, 6 is the most common password. So that's pretty cool, but we can look at a couple other things. We can do analysis like that using just raw Python too. Oh, actually, one other thing that I want to show you here that I think is really cool is so you can do where clauses in this. And so if you want to, this is a little concerning. If you look at passwords that are like the word security, there's a lot of them. So there's like 40,000 that are the word security. I think that's 8 characters. The irony there doesn't escape me. But you can do this too. One of the really cool features of Zeppelin is that you can do this kind of like variable replacement here so that you can say, I want to filter on this password field where it's like security. And so then you can fix it. You know, you can put in anything you want. Like a lot of people have the word Kelley. It's very flattering. So this is really cool. This is a really cool tool that you can then like hand off to people that might not be you know, able to write SQL or might not want to write SQL. You can hand off this tool to, you know, an executive or your manager, and you're like, look, I built this cool thing, and they just have to input a field. And so I think that's a really powerful thing that I like that makes this tool really useful to a wide audience. But we can do that kind of analysis using raw Python too, using not just SQL, but a SQL-like DSL that we were looking at earlier. And so we can do that with, if we want to look at passwords, where the password column, let's look at some more suffixes. And so we can do this using the like option. And so we'll look at the things that are like, have a suffix of 1, 2, 3. I'm going to go ahead and copy the code from up here, so I don't have to type that again. And now we can show that. And so you can start to see the types of things that people are adding to their passwords, all the very common passwords that have 1, 2, 3 at the end of them, which is, yeah, so that's actually interesting. People have noticed MySpace. So this basically means that, so MySpace got hacked in 2016. And so a lot of the data in this dump came from the MySpace dump. And so there was a ton of stuff that had the MySpace name in it. We can actually look at that if you want to look at things that like contain the MySpace word. There's probably a ton of them. So like look at all this thing that people are adding to their passwords. Like the MySpace one, like MySpace probably had a rule that you couldn't make your password MySpace. Like, oh, no, never mind. These are just the people that thought they were getting creative, but I digress. So this is the point about this is that, you know, all those password sites that have, you know, like requirements of this, like must contain a letter and a number. Like they think that's being more secure, but it's not, because when you make the requirement that you also have to have a number, people are adding the same numbers to all the same passwords, and it doesn't actually add any security. That's my rant. So I'm going to switch back to the slides for a minute, but finish up here. So yeah, this is basically what we just saw. So this guy is like coming up against these password requirements, and it's like, oh, you have to have a number, you have to have a special character, and so he ends up with password 1, 2, 3 exclamation point. And yeah, that's not even a secure password, but it fits the bill of, you know, the security requirements that they laid out for him. And so to him, you know, this is a secure password, and we can't blame him for that because that's what the website told him. So anyway, I do want to highlight some of the benefits of Spark. I think it is a very fast and flexible engine for doing data analysis, and I think it's really good for exploration, especially with some of the tooling that's been built on top of it. And I really want to emphasize that this project has only been around for like 4 years, and so it's really impressive the number of large companies that are using this to do a lot of data analysis. Twilio uses this extensively internally for doing some of our data analysis, and so it's definitely deployed in a lot of large companies. And it's definitely something that you can trust, and it's been proven for very large systems. Unfortunately, it's not without challenges. There are some very opaque error messages that you kind of just have to get used to reading. I mean, it's like a lot of stuff with development. You have to know where to look. But I do want to highlight one of the error messages that you might see, especially with working with PySpark. This is something that I originally tried to do. I thought that the ordering by a descending operator would work, and it doesn't. But it does call out the error that happened, but you'll notice down here that you get a Java stack trace nested in a Python stack trace when running PySpark, and that's not exactly what you would expect. But like I mentioned, Spark is built on top of Scala, and Scala, for those of you that don't know, runs on the JVM, and so there are going to be Java stack traces embedded in this, because at the end of the day, there's Java executions that's happening here. So there's an entire talk about debugging PySpark that was at my friend Holden gave at this year's PyCon. I'm going to point you there if you have trouble with this. I'm so sorry. It's not very great, but I promise that they're actively working on making it better. So I did want to wrap up with just talking about some of the implications of big data and security. We already talked about this a little bit, what we can do with password requirements. And really, in some ways, this is going to sound crazy, but I think we're a little lucky right now as security professionals that data privacy is on everyone's mind. It's not really a good thing because of things like Equifax, and I mean, GDPR is probably overall a good thing, but I think it probably makes our job a little bit easier as security professionals to convince people that this stuff is important. And I think as we go into our development teams and management and convince them to add resources for making sure our stuff and our data stays secure, that we can point to things like this that we don't want to be the next Equifax that gets hacked. That can really ruin companies. We can't separate security from development anymore. It's something that really needs to be on everybody's mind. And people like me are going to be up here hammering that point until you get sick of hearing my voice. But I think it's something that we can work together as a community to try to make sure that people are mindful of this stuff as we continue to build systems and build them securely. Because nobody's security is perfect. So if you have any influence over the security at your company, especially if you're just here as someone that's security curious and maybe your company isn't big enough or doesn't have the budget to have a security specific team, make sure that you're storing passwords, you're salting your passwords so that if they do get breached, people can't back out the plain text passwords as easily. Storing those and other PII securely. And be an advocate for not storing as much data, more data than you need. That's a big thing that you can do as a security professional, making sure that marketing might come to you and say, we need all the analytics, and you might not, because if you store all of the things about people, that's just opening you up for new challenges if that data gets accessed by somebody that shouldn't have it. So this tweet, if you haven't seen it before, it was revealed that T-Mobile Austria was storing plain text passwords, and unfortunately the security agent really doubled down on the possibility of that being a problem. So just don't be like that. Just recognize that this is a thing that you should be storing your passwords, not in plain text. And so it's also up to us to find ways to improve the user experience while we keep things secure. I think it's completely forgivable that people have bad passwords. We haven't done a great job of making the experience easy to use. Passwords, they're not great, but they're also not going away anytime soon. Things like password managers are a relatively recent phenomenon, and they're not super widespread. I'm sure that within this room they are, but if you go out into the greater population of people that use the internet, there's not a huge percentage of people that are using password managers. And so one-time passwords are always an option. This is an example of how you log on to Lyft with a one-time text password, but even that's not a perfect solution. We know the security vulnerabilities with SMS. There's tons of issues with that. So I think it's up to us as developers to take on the responsibility for securing authentication. This is another way of doing one-time passwords. Magic links at Slack is another way of doing that. Though I wish they wouldn't say, like, if you just reset your password, hopefully to something stronger and more secure, like, I don't even know what that means, but the magic link is a good idea. So if you're a developer, you should think about things like adding reasonable password requirements to your website. If you work at a company that has something like, you must have a special character and a number and a character, like if you have something like that, I can send you lots of literature on why that's not a good idea. Offer one-time passwords if it makes sense for your application. Like I mentioned, Slack's magic links are an example of that. Text-based one-time codes. We're seeing more ways for doing this. 2FA, I'm obviously a big fan of 2FA. It's a great solution to help guard against password stuffing. If people get access to credentials but don't have access to the second factor, 2FA can help guard against this. And this is an example of push authentication, which does require that somebody has an app installed on their phone. But this is giving a more seamless user experience because then you can click accept or deny instead of having to type in either a one-time code from a TOTP app or getting the text message, which also has its security problems. So if you do need to rant and blame someone, I highly recommend this Twitter account. It's called Password Too Strong, and they retweet all of the password problems on the internet. It's a good time if you're somebody like me that likes to geek out about this stuff. And so this guy has an example of how IBM inflicts, I don't know what the security-focused tool is, but some of those requirements that I was mentioning, like it does have a maximum password length requirement. It doesn't allow spaces or some things like that. And so it's a good place to vent on the internet, which sometimes we all need. If you wanted to read more about this, I can recommend a couple of links to you. I will tweet out these slides right after this, so you will have those links. I think Spark is a great tool, and you can do a lot of powerful analysis for things like looking at the password data that we saw tonight. I think this is just my alter ego. I just like this slide. Hopefully, I've given you some insight into how to get started with Spark and what you can do with it, and also inspired you to think about your password requirements. Come find me after this if you have any questions. Once again, my name's Kelley Robinson, and thank you for listening. Do I have time for questions? Questions? All right, I'll be around.
All right, thank you, Kelley. We have this adorable segment-branded Coca-Cola and a ticket to Synapse, our user conference.
Oh, yeah.
I actually am kidding. I don't know what's in this.
Oh. Well, don't make promises you can't keep.
Go find Joseph and threaten him.
Okay, I will. Thank you.
All right.
Thank you.
Up next. Yeah.
You did your job.
You guys can hear me? Cool. Oh, it's a good start. Good start. Just one more second, guys. Sorry about that. That's the wrong one. I'm just gonna give up. Who needs those notes anyways? Okay, cool. Real quickly, I'm gonna be talking about efforts in scaling application security programs. So really this is gonna be a retrospective talk on kind of the work our team has done over the past 4 years. So let's see if this guy works. Yeah. So quick intro, my name's Eric Fay, native Scrantonian for any Office fans. You can drop any reference for me. So if you have anything, let me know. So I'm current manager of application security at Hulu. And before that, I was working in InfoSec at Dow Jones back in Princeton, New Jersey. Quick gifts. Unfortunately, I'm going to be condensing a lot into this. So the meme and gift count's really low. So I apologize for that in advance. So yeah, I'm going to go through kind of what the agenda is. Like I said, it's going to be a retrospective of how we started the program at Hulu, for the application security program at Hulu, how it's grown and how it's kind of kept up with the success of Hulu and kind of what that scale looks like. So the timeline is 2014 to yesterday, or some ongoing stuff. So it's, again, I'm going to be condensing a lot. So and glossing over. So if you guys have any questions, feel free to chat me up afterwards. And if you're a vendor, my name's Eric and I'm wearing a Segment shirt. But if not, I'm wearing a Hulu shirt. So I broke this up into like general phases throughout general like open pastures. I didn't want to do like quarters, years, quarters. It was a little bit too much, formally, because it was, to be honest, a few years we're all over the place and we're spinning around just trying to catch up with all the development and infrastructure and all the scaling. So I'm going to go through a few phases there and we're going to break it out. So this is open pasture phase around 2014, somewhere in there is when I first joined. So it was the first application security hire at Hulu. So I'm going to give the landscape of like kind of each of these phases and what was in place and some of the development processes and what services that were available currently at Hulu, or at the time at Hulu. So really what the landscape was, I was hired first AppSec hire, and nobody before that was full-time AppSec hire. So it was really just a bunch of smart engineers that cared about security and some that didn't, and some that didn't focus on it as much. It's not in the forefront of the mind. So at the time, there was a lot of monolithic applications that were powering the site and the service itself on the web. So specifically, there's a few gigantic Rails applications that were that were in place at the time. And service-wise, at the time, we had a free video on demand, so you could just sign up and just get bashed with ads. They'll watch your content. It's pretty heavy ad load. And we had a subscription video on demand service as well at the time, so pay a little bit more, less ad load. So some of the goals that we kind of set at the time frame, again, this is going to follow the same structure throughout for each of these phases. Some of the goals was just learning the lay of the land, determining what was business critical to Hulu itself and just to the business, what would be a direct revenue impact to Hulu, and of course then what would be a detriment to the actual subscribers and users themselves. So things like playback, play start, sign up, account management, stuff like that. So we really try to focus risk and vulnerability identification on those workflows to begin with. Again, we're just trying to catch up at this point. The company was founded around 2007, 2008, so we got a lot of catching up to do. And again, at the time, it was 2014. So one of the other goals was establishing relationships with dev teams, all the different dev leads and different that were responsible for those critical workflows. So yeah, that's one thing I'm gonna touch on a bunch that was super invaluable. So next step was kind of what the actions we took, met with dev leads and tech leadership to try to figure out what just really learn what the architecture was and how the services, what applications and services powered critical workflows for those workflows for Hulu. So from then, we kind of shook the tree of the services to find what vulnerabilities were there because no one had been looking for them full time at that point. So we did automated testing in the form of a DAS tool that we had. And then after that, we kind of the low-hanging fruit of, XSS, CSRF, all those things, easily findable by certain tools, or at least they do a decent job at finding them. And then try to focus a lot of work on doing manual testing for those like business logic abuse, things that tools aren't going to find, and just shake the tree again on those for those critical workflows. Again, required a DAS tool to kind of do that. So some of the lessons learned for that phase was dynamic analysis in this phase was really good at just, again, shaking that tree and finding the low-hanging fruit and automating that flow of just continuously scanning and looking for those vulnerabilities. And that really, in retrospect, a lot of diminishing return kind of from what we got then to what we got today is a very diminishing return. Establishing connections was probably the most invaluable things, creating those feedback loops of, oh, hey, we're meeting dev teams and we're creating this. What do you guys think? So this informal feedback loop was something that was very crucial for years and years. I still have some of the dev leads I've originally met with back then that are still working at Hulu. So obviously that's a great working relationship. And so we know how to help them best and how their service and architecture is set up. So then also just one miscellaneous note, success criteria is drastically different for some type of vendor or tool assessment than it was in 2014 as it is today. The next phase, general expansion of growth of the program, kind of starting to mature it a little bit, was around 2015, 2016. So a little bit of landscape. We kind of know we're familiar with the apps and services at this point that are driving those business critical workflows. We've identified and remediated some of the immediate risk and vulnerabilities, which is great. We're the security go-to for a bunch of different teams. Again, more good stuff. And at this time, we're about 1 to 2 full-time application security engineers. Excuse me. So in our case, it was 2.5, I think, actually, AppSec full-time. One of the engineers was part-time or as an analyst helping us out, triaging different issues. And just generally speaking, our team started moving over to microservice architectures a bit more than kind of away from the monolithic applications that we had previous. Got rid of FOD, which is good and bad for some people. Subscription video on demand's there. In this time frame towards the end, we rolled out no ads, subscription video on demand, which I think everybody was really excited about, especially internally. We're all something, I know everybody was asking for it, and so were we internally, but, and also some add-ons, so stuff like Showtime, adding it onto your account. So some of the goals for this phase were creating tools to kind of automate the stuff that we were doing, because we were doing a lot of manual work, manual spot checking of what was, testing and just risk identification, expanding the tool coverage that we had for identifying these vulnerabilities, getting security actually in the SDLC, because at that point we were really far removed from it, and we were finding vulnerabilities in production and on production services. So really late, there's a huge gap of dev deploying something on a laptop to pushing out to production, obviously. And then some type of secure code education as well, just getting teams and developers in the know for what are these issues that are constantly being introduced. So some of the actions we took, we acquired a RASP tool. We also started a bug bounty program in this phase. So there's a little bit of, I know there's a lot of argument back and forth about when does an application security or a security team start a bug bounty program. I think for us, we started pretty early, because at that time, again, it was about 2 engineers, maybe 1 analyst part-time. I know there's kind of a back and forth of when to start one of them, but I think it was definitely a good decision from us, and we scaled out very slowly, which kind of helped us ramp it up over time. So I think at the time when we started, it was about 10, we invited 10 researchers to the program, and at this point we're over 500, so it's definitely grown over the past 4 years. It's been definitely a great program. And we built a lot of internal monitoring tools. So again, we were spot checking a lot of these things and seeing root causes come up or issues that were just reoccurring and like constantly. So a few of those things we've tried to build some tools with internally at the time. Again, we were trying to automate a lot of this away, a lot of the work away. So one of the things we did, we built an automatic static code analysis tool for Rails specifically, because again, at the time we still had some gigantic Rails apps that were powering the huge chunk of the site and actual Hulu itself. So we built that, and that just listened to Git hooks and then looked if it was a Rails app, and then kicked off Brakeman to just leverage the open source tool Brakeman to do the scanning. And it also notified devs in changes of vulnerabilities. So, hey, you introduced this vulnerability, maybe it's great to go look at it, and quick email or Slack, HipChat at the time, whatever it was. So, and also the same reverse was, oh, you fixed something great, awesome, you're the best type of message, maybe a cat GIF or something of the sort. And we also created something for monitoring the external surface of, at this time it was a very big growth of what services and the growth of users, growth of the company. So this surface, we didn't really have a good grasp on what the visibility was to us, what our attack surface was, where the attacks and vulnerabilities were really coming in. Because at that time, the developers had a lot of, well, I mean, they still do, but there were a lot of freedom to just build something, deploy it. It's out on the internet. Anybody can go touch it immediately at that time. So we had built a tool to just hook into load balancer APIs and one or two internal shared services tools like an internal PaaS system. So platform as a service like a Heroku, but it was internal to us. We hooked in there to monitor what was changing on the surface, and it drove a lot of good metrics and data for us, and just to keep track of, why was something exposed? We can start asking those questions when before we didn't really know what was exposed beforehand. Something called leaky buckets, which was just an S3 access monitoring tool. So things that were looking for weak access controls on buckets. Again, these are all kind of coming out of different flows of metrics that were being emitted. So bug bounty program, we keep seeing these submissions of people, maybe placing or getting some control on a bucket. But so we kind of created those tools out of necessity, and holding internal security talks with those teams allowed us to focus in on like, hey, at this point, at some point there was 50% of the bug bounty program was either cross-site scripting or CSRF. So if that's not a theme to anybody, I'm not sure what is, of saying, hey, there's a root cause somewhere. This is being, half our submissions are that. It might be, maybe that's something that's easily automatable, or there's some type of team or like education issue, or the actual framework itself that some teams are using are introducing these vulnerabilities. So some of the lessons learned, for us, we tried that REST solution, and we integrated it into one of the monolithic applications at the application level. And it was a very high effort for us at the time. Again, it was 1 to 2 engineers, and Shitra in the back actually was the one that was working on it. So you can go ask her for more details. So at the time, it was a lot of effort and taking up one engineer's time for a mess of a quarter, something of the sort. And it was really only covering 1 to 2 specific vulnerabilities. And at that time, there was a big move to microservices, like I mentioned already. So that monolithic app was getting chunked away into different services and different functions. So that really was something, lesson learned, that we probably did at the wrong time. It might work for other teams, but at that point, it didn't work for us. And the monitoring tools had like varying degrees of return on investment for what was really useful. The static code analysis tool I mentioned we built out was a hackathon project. I wrote it, spaghetti code, maintenance was really bad on it. I'm gonna be honest with you. So we didn't work that much, but some of the tools I mentioned before are still running and still getting us good return. That external exposure one I mentioned is still up and running, and we're able to see how our external attack surface is like moving and shifting on a constant basis. Again, bug bounty was an immediate return. It kind of augmented the testing that we had for some type of manual testing that we really didn't have enough time to do. And we got a lot of valid findings out of it, but the warning I would say is for this and other teams is to scale very slowly, because it can get it can inundate a team very quickly. So I'd say start small. There's no reason to rush it, regardless of how aggressive some vendors want to push you publicly. Yeah, there it is. So yeah, it was a great return. So I would say definitely look into it. And like, again, we've kind of went a little bit faster on it. Focus talks with individuals creates more feedback loops. We kind of took data from, for example, the bug bounty program. We're able to see that these teams were introducing CSRF. So we went and talked to them about it and say, like, did a little bit of education. Some teams didn't know about it, didn't know what it was, weren't familiar with it. It's not really on the forefront of their mind. They're supposed to be shipping features, so why should it be? So we went and did focus talks with them, and that was good because it created more feedback loops for us, for them to reach out, and devs that may not normally work with us to say, oh, that was cool. Do you think it's applicable to this app or this service? And again, more feedback loops, the better for us as a team. So at this point, 2017, 2018, we're getting a little closer. I'm almost done. I swear I don't have too much more. So maturing the program, kind of what that looked like just for us was, in this phase of having 3 to 4 full-time application security engineers with 1 or 2 analysts kind of hopping in and helping us with triaging of different events and either incidents or things like our bug bounty program. Teams are moving to centralized CI/CD processes, which is obviously great for us because we're able to hook into those things, whereas before teams were siloed in their own build process and their own SDLC. So it allowed us to hook into some stuff there. Everything's a microservice. There's so many microservices at this point. I don't know what it is, the count is anymore. The monolithic apps are basically just shrunk completely. So that's definitely one big change. Since 2014, we were able to stare at like one or 2 Rails apps, for a huge chunk of what the site did, what the web interface was, and how the clients interacted with it. And now we're at, I think the internal path system I referenced before is a few thousand applications on it, which again, they may not all be production apps necessarily, but just kind of giving the ballpark of how much we've kind of cut down into specific functions and features. Service-wise, we're at SVOD, subscription video on demand, and no ads. And then more add-ons. So I think we added HBO and a few others as well. So add it on your account, get to watch HBO via us or via Hulu. Live TV also, which is great. It's been really exciting trying to get that, or getting that going and out the door. But obviously there's a lot of challenges with that as well. So some of the goals for this, what we really wanted to focus on in this portion was remediating classes of vulnerabilities and org-wide risk, and kind of getting out of those specific, fix this XSS, fix this CSRF on this application. Get security further in the SDLC process. Again, we've got 1 or 2 things that are in there, and just pushing that further down those pipelines. A few internal things like formalizing workflows for our team and increasing some of the efficiency of how our team operates and works, and formalizing security education. So some of the actions we took, static code analysis in CI/CD pipelines. So that looked like, again, I mentioned they were starting to consolidate, and teams are using a shared service version of CI/CD. So kind of looks like Jenkins internally. So we're able to hook into that, use a static code analysis tool to, again, just onboard teams, go by criticality, go down the list and onboard them into the tool. So they have, it's just another build step. To them, it's not just another build step, and instead of some huge onus to go reach out to security does a scan, here's 10,000 vulnerabilities, nothing's ever gonna happen, obviously. Security involvement in one of our external exposure processes. One of our shared services teams, our DevOps team, was responsible for kind of pulled in some of the responsibility for exposing VIPs or apps and services out to the internet. So we kind of latched onto that and said, hey, let's try to get some security reviews or assessments on those applications before they go out the internet. If it's something that's brand new and no one's ever seen before, if it's clones or different environments, different data centers, who cares, just let it go type of thing. Obviously we're not going to be that much of a blocker to those teams, and we don't want to be ever. So that was one other thing we did. We created a checklist for best practices for those teams to follow, and they answer it to us and say, hey, did you follow this best practice? HTTPS everywhere, Is there any PII involved in this application? So is it touching emails? Is it responsible for viewer histories, things like that, of that nature? So, because sometimes we're not going to care about the app realistically. There's a lot of marketing stuff that goes out that's just static pages. Do I care about that compared to something that is modifying viewing history or touching viewing history, or even more sensitive, the credit cards coming in the sign-up flow? So we have to prioritize, obviously, still a pretty small team. We acquired a WAF solution that we put in place into that internal pass system I mentioned before. So we made sure to minimizing development work for those teams. So that ended up just being we work with our DevOps team to make that a one-click feature for all the apps that go out on that. So it's enable WAF, deploy, you have WAF. So no rule writing, they don't have to worry about the maintenance management of it at all. It's just a feature, another feature on the pass that they have. And we acquired education, secure coding education content, and put that into being good, responsible hooligans. We worked with our internal teams to get onto the learning management system that they already had. So then we also created a pipeline for doing education for onboarding of developers in one of our sensitive or more secure networks that we have. So before they can enter as like a little gate, they get educated on OWASP, Pwned, and PCI specific things, or a few other more, depending on what network it is. So it integrated that, and we also started working on content security policy as well. So that was one thing that we've been working on relatively recently. We have successfully rolled out on, right now it's just 1 or 2 applications that are supporting Hulu employees. So examples, SSO for our Hulu employees it's rolled out on too. So we want to make sure we're doing that correctly, and that's kind of a portion of the lessons learned. Excuse me. So some of the lessons learned from this process was static code analysis and the CI/CD integration is very valuable. Again, getting security further in the SDLC and trying to get it more as a build step rather than this nebulous security team process and scanning tool. And of course, getting vulnerabilities and getting in front of them as just admitting those vulnerabilities as a build step for those teams to look at. Again, hooking in established processes was a very low friction for our team and also for the development teams that we're working with. So instead of us going and saying, oh, we have to do assessments on everything, we also don't want to do that because it doesn't make any sense, and there's 3 or 4 people on the team at the moment. So that was a lot lower friction, but we still got a lot of return back on that as well. And again, we formalized a lot of internal workflows for doing assessments, stuff like that for our team, and that's adding rotations to things like our bug bounty program, adding rotations to our assessment workflows, obviously, so one person isn't getting burned out dealing with people that just submit, I'll say, shitty bug bounty submissions all the time. Realistically, it's just emitting scanners, stuff like that. So we try to reduce that friction there too. WAF integration was a really high return on us because it took a little bit longer to get in place, but we also, again, we focused on minimizing the work for the development teams to get it as a feature for their applications. And then we made it easy enough that we were able to roll out to all the external applications that were on that pass system. So, to this point that where we're at, it's in the ballpark of at peak, maybe 150, 160,000 RPS that it's taking on. So, it's been scaling out very well, and it's something that ends up blocking on the magnitude of 8 to 10 million requests a week at this point. So it's blocking millions of requests. It's been a great return, but also there are a lot of shitty WAF solutions out there. I think for the security folks in the room know that already. So just be smart with it, with your success criteria for what you're looking for. As a lesson learned for one thing I definitely would have done, again, as an honest retrospective, gone back and done the formal education a lot sooner than I did, because it was pretty late, or than what our team did. It was pretty late in the process, and we're really just formalizing it right now. I think we kind of could have bridged a lot of gaps that way. We did it a little bit earlier. And CSP is hard to scale properly. I don't think that's a shocker for those that are trying to deploy it or have deployed it, to doing it properly and not turning your team into the team that's managing whitelists, managing domains for all the different properties you have. So for us, that was us focusing on certain frameworks and doing noncing automatically at the framework level and then using Flask Talisman specifically. So we've been leveraging that, and we're trying to scale that up scope-wise. So yeah, future, kind of what we're looking at with some of the project we're looking to take on, some of the things we're trying to play with now. Automated vulnerability exploitation. So we have a lot of, again, like I said, a lot of requests coming in per second when it's at peak, where like the service is at peak time. So we have a lot of data we can be pulling from, and things that like anomalous detection, we already have some signal from something like the WAF. We're able to pull that out, all that data out, and start looking for, are there signs of something actually getting exploited, instead of somebody just throwing an automated scanner at us and nothing's happening. So just, you know, scanning some static page, that's never gonna fire. So things like that, getting tighter security integrations to SDLC, maybe doing some DAS stuff in there as well. We were focusing mainly on SAST for those build steps. Education events, we've been toying with doing a CTF internally, which we're only a few challenges off. Hopefully we can get out in the next few months. Should be a lot of fun for the teams, and just get all the tech teams and dev teams involved, give out some rewards, something of the sort. And kind of focus a little bit more on creating security libraries for the teams that ingest. Things like security headers we should be able to provide them libraries with pre-configured security headers that give instant return back. So focusing a little bit more on that. And then just generally speaking, pushing security is just another consideration for the dev teams. Instead of this, again, it should just be what we're finding in the end of the day from all of these things are just bugs. They should just be viewed as bugs and ingested as bugs and fixed as bugs, just as with the appropriate priority. So, you know, getting further in the SDLC has helped us a lot with that, instead of kind of viewed as some nebulous type of thing. So that's what I got. That's one of my engineers. He's gonna kill me if he knows this is up here. He's hacking the planet. He's hacking the planet, and I don't know if you guys can notice, but some of those laptops are not upright. So that's all I got. This is my Twitter contact and some on LinkedIn. Appreciate the time today. So I hope you guys learned something, and feel free to come and chat. Thanks.
Test. Sweet. We're on. Hello, everyone. I am David Scribonia. I do AppSec here at Segment. And I'm here today to talk about usable security tools. So creating usable software, I think, can be a difficult thing to accomplish. And specifically with security tools, I think the user experience often gets overlooked. But I believe that by creating usable security tools, we can provide not just a more pleasant user experience, but we can actually improve the security of an organization. So I'm going to talk about why I think UX can lead to better security and how we approach this problem of usable security tools with a Z attack proxy. Before I go any further, I want to talk about what I mean about usable. So a usable software, I think that it should be intuitive, flexible, and efficient. By intuitive, it should be easy to pick up and start using with almost no prior knowledge. By flexible, it should be configurable and customizable, really be able to customize it to someone's user use case. And it should be efficient. Even though it's simple from the top, you should have an organized way to get access to more powerful features. So a great example of this was the iPhone. When the iPhone was first released, it was far more intuitive than any of the other tools out there. Anyone could figure out to click the button and it started a new app. Click the home button, it would take you back. Swipe left or right. Oops. But it was also flexible. So I think we overlook this feature, but being able to rearrange your apps on your different home screens allowed you to prioritize the functionality of your device. And it was efficient. It's super simple, an app on the front, but has access to all the powers of an iPhone. Now, you might look at these three words and say, well, any good software should be these things. You can imagine some software that is really good at solving a problem, but still isn't intuitive or flexible. I think usable software leads to a more efficient organization. If the tools that your employees are using are more intuitive, more flexible, you're going to be able to do the job quicker, more easily, with a little bit more joy. And by that same token, I think usable security software leads to a more secure organization. Not only is it going to make your security team better at their job and make them quicker at it, because we all know too that security tools that we've been using aren't the best to operate. I'm sure everyone here can imagine a tool they've used recently that's been kind of a pain. Besides just improving the experience of our security teams, we can also improve the experience of our developers. By making security tools more usable, we can make them more accessible to our developers and QA. This is the point I really want to dive into. Enabling developers to use security tools will improve the security of your organization. I think security teams can often silo themselves off, taking the full responsibility of security. But security is everyone's responsibility at an organization. I think we see this push left often. There's more and more we see how do we introduce security automation into the CI/CD pipeline. There's movements like the DevSecOps. All these are kind of like buzzwordy trends. I think they're rooted in the same fundamental truth. And again, that security is everyone's responsibility. So if we empower our developers to include security in their workflows, we can ask them difficult questions like, can you test this specific part of our web application for broken access controls and cross-site scripting? I think this would be a difficult question to pose to any team's developers. So what can we do to bridge this gap? What can we do to make security tools more usable? So I want to talk about how we address this problem with a Z attack proxy. So if anyone's not familiar with ZAP, this is an attack proxy that allows you to test the security of your web application. And the way this works is that you'll run ZAP and you'll boot up your browser and go to your web application. And as you go through your web app, the requests are going to get proxied by ZAP, forwarded onto a server. And when the server response comes back, they'll be intercepted again by ZAP and forwarded onto the browser. So if you're using ZAP, your workflow might look something like this. You might have ZAP open in one window and your browser open up in another. And having this position as this man in the middle gives ZAP a ton of power, right? You can intercept requests, replay them. You can fuzz sites. You can spider the entire thing. With passive and active scanning, you can look for things like SQLi, XSS. It's an extremely powerful tool. But I don't think it's necessarily trivial for someone to pick up and start using. You have to learn how to configure it, how to find all the features, how to make sure that you know where all the different parts of it are. I mean, even for security professionals, you'll probably have to go through some sort of training to understand how it all works. So we asked ourselves on the Zap team, what can we do to make this more accessible for our developers? We decided to take our inspiration from heads-up displays. This is an example of a heads-up display in a fighter cockpit. We can see things like the speed, the acceleration, the altitude, things like the bore sight, and this is where your nose is pointing. Things like the flight path vector, and this is the actual direction the plane is heading in. Things like the angle of attack, which is the angle of the wind relative to the wing. All of this stuff in a very simple, intuitive display. And imagine if all this information was instead displayed on a bunch of gauges and knobs. It'd be so difficult for this fighter to now look over this entire dashboard and try to fly a plane at the same time. Another great place we see heads-up displays is in video games. We have our mini-maps. We have our objective markers. You can see our ammunition and our health. We even have dynamic overlays over the other players, indicating friend or foe. And again, imagine if we had to instead view this in a really intuitive way. If we had to pause the game and look at a separate menu to get access to the information, it'd be impossible to play the game. And so with that, I'd like to introduce the Zap heads-up display. We take the same principles of usable software and these design decisions made in heads-up displays to recreate how you use Zap in a more intuitive way. And so with that, I have a video showing how it works, but that's just in case the live demo fails. So let's see if we can make it happen. So what we have over here is Zap running on the right side of our screen, and we have Google loaded up on the left side. We can see that Google's been marked up with our heads-up display. So what we've done is we've taken all the features of Zap and encapsulated them into what we're calling tools. So we have a tool over here to show the different alerts on the page, or the different alerts across the entire Google site. We have the scope tool, which allows us to define what URLs or domains we want to include in Zap attack. And so if we were to turn this on and add Google to our scope, you'll see that it's been added to the scope in Zap. But of course, we don't want to attack Google. Let's go to another site. Let's go to something we're running locally. And you can see that when we load the Juice Shop application, the heads-up display loads along with it. There's a couple of other tools that we have in here. We have this Sites tool. The Site tool will allow you to explore the site tree, just like you would in Zap. Of course, you can see all the different files that make up the site. You can even run the spider right from the heads-up display. So if we add this to scope and we start the spider, you'll see that it triggers off right up here in Zap, and now we're spidering the site. And so the design decision that we had to make here was that even though we're potentially restricting or limiting the freedom of all these different features by kind of encapsulating them in these simple tools, we've made them so much more accessible now. Anyone can boot up their browser and understand how these different tools work. I want to go back to the slides to show how this kind of works underneath the hood. So just like we were using Zap before, with requests going through Zap and responses coming back, when we're using the heads-up display, we're actually going to modify this response that we're sending back to the browser. We're going to add this script tag that has a reference to a JavaScript file that's going to be served back by Zap. And what this file does is that when you load your target page, it's going to introduce, it's going to inject these different iframes directly into the DOM and put these iframes and build the different components of the heads-up display. If we go back to the demo, we can see that we have these different iframes over here. We call these iframes on the left and right the different panels. And I mentioned that we wanted this to be flexible. So these panels are designed to be completely configurable. So let's say we wanted to add a new tool over here. We can add the Show Hidden Inputs tool. It gets added to that side. Or maybe we don't really care about these informative alerts. Well, we can just click on them and remove them so that they're not in our panels. In the injected script I mentioned, it doesn't just load these iframes. We now have a powerful foothold on this target application that we want to test. One place we can see that is with that hidden, show the hidden inputs tool. So if I go to another application I'm running locally to test against, oh wait, actually, I want to get here. Let's go to a real site. Let's go to the OWASP login page. You can see when the OWASP login page loads that our show hidden tools, it's now showing a data field of 6. It means there's 6 hidden inputs on this page. And if we click this tool, it'll now display all these different hidden inputs. We can modify the tool, the target page with our tools. If I go back to the to our slides, the next part of this architecture I want to show off is the service worker. If you haven't heard of a service worker, it's basically the same thing as a web worker, which is a background JavaScript thread that runs in your browser, except in this case, it has a few extra privileges. Whereas a web worker is booted up and dies every time your page loads, a service worker can persist across multiple page loads. And so the design decision that we made here was we wanted to make sure these iframes, the heads-up display, was extremely responsive. And so we took a bunch of the functionality out of that and put it into the service worker, which then communicates to them via the post message API. And I want to point out at this point, we're not using any browser extensions. The heads-up display can run in any single browser using just Zap. So if we go back to the demo, one of the key tools that uses this service worker is the break tool. The break tool allows us to intercept messages. And so if we go to Juice Shop and we turn on the break tool, we're not going to intercept any message that we send. So let's say we search for Apple, and we'll see that the message gets intercepted and displayed to us right back in the browser. Of course, we can modify this, and let's change our search query from Apple to orange. And if we press continue to allow the request to slide through, we'll see that we've changed the message that was sent. And so the last two pieces of this architecture that I want to show off are the Zap API and the WebSocket. So to connect the heads-up display back to all the power of Zap, we leverage the API. If you haven't looked at this, it's extremely extensive. You can basically run the entire Zap application through the API. We also have this WebSocket. This allows us to stream data and events that are occurring live in Zap to the heads-up display. So every time a message is intercepted or a new HTTP request goes through or a new alert is discovered, we can see it right away in the service worker or in the heads-up display. A couple of the tools that make use of that, one of them is the alerts. So if we click on this, it'll show us all the medium risk alerts we found on the site. Of course, we can explore the low risk alerts. If we were to click on this, it'll show us the specific alert and all information about it, indicating where it believed it found the problem. And the second part that uses these things the most is in this bottom drawer that I haven't talked about yet. If we click on this and open it up, this shows us the history, just like you would see in your developer tools. Except this one's linked up to Zap. And so, of course, if we were to change and search for this again, it'll show us on the bottom our last message that we sent. And if we were to close it and search for something else, it's going to notify us when a new message has been sent. If we click on one of these, again, we can inspect it. We can see the request that was spent. We can see the corresponding response. Well, let's replay it. So let's change orange back to Apple. If we replay this in the console, it's going to display it back in this modal. You'll see that the JSON returned is now indicating that we searched for Apple in this case. Now, the last tool I want to show off that we've built is the attack tool. Let me go back to this other test application. If you haven't used Zap, the attack tool will have Zap hammer wherever you're browsing with everything that's got. Any XSS payload, SQLi, it's going to start crawling it. And so if we add this attack tool, we add budget to our scope, we go to the search field, as soon as I turn on this attack tool, you should see Zap start to hammer it. When we turn it on, and we can see that Zap is now hitting it with a bunch of different requests. And so if we search for something here, we send that through. It's going to keep sending different payloads at it. And if, let's see, there's a specific payload that I want to hit it to show up one of the cool features. If I turn this off and back on and search for it again, oh, there it comes. So if we go back to the search field, it's recently just found an alert for cross-site scripting. You can see what the HUD's done is actually mark up right on the target page where it found that vulnerability. It's showing us that in this form, there's a cross-site scripting error. And if we were to click on this flag, which indicates to us that it's a cross-site scripting issue, it'll actually show us the information regarding that alert. But the goal of the heads-up display isn't for the Zap team to build all these tools. We really want to enable other people to build their own. We've developed the entire framework to support this idea. And so just to show you how easy it is, we're going to build a new tool right now. So there's the scripts add-on in Zap that allows you to define new scripts that you want to run and hook up to different parts of Zap. So I've already defined this script right here. It's called Hackit. And all it does, this is a Zest script, which is just a weird visual scripting language. And all this script is going to do is that wherever in the response body it sees the word budget, it's going to replace it with Hackit. We also see in this scripts area that we have something called HUD. If we open that up, we can see all the different files that build the heads-up display. And so we're going to copy one of these tools and modify it just enough to create a brand new tool. Let's see here. We're going to call our new tool Hackit. We have this duplicated code, and there's only a few fields we really need to change. We're going to change the name of our tool. We're going to change the label, which is what we see on the tool button. We'll change the dialog so that when we select the tool, let's be disabled. So when we select the tool, it shows what message we want to display. And we'll turn this to enable. And the last thing besides that is just changing the functionality. And so you can see we have these two functions, turn on attack mode and turn off. And these are just what happens when we turn the button on or off. And you can see there's a request in there, and that's to the Zap API. So I'm just going to change that to instead hit the API for turning on attack mode. We're going to hit the API for enabling a script. So I'll copy and paste that right here and change this to disable and hit save. And that's it. We've just defined a new tool for the heads-up display to use. And so if we were to restart the heads-up display, which right now isn't built into it, so I got to do this. As we reload our test application, you'll see the heads-up display restart and refresh. We should have the ability to now access this new tool we just defined. And so if we click on here, there it is. This is a new tool that we just defined. And if we add it to our panel and run it, and go to a new page, we can see that instead of saying budget, it's replaced it with the text Hackit. This is kind of a silly script, but you can define whatever functionality you want in these scripts in JavaScript and Python, whatever you want, and link it in less than 3 minutes right to this heads-up display. So looking ahead, we're really going to be focusing on developing this framework to help package your tools so that developers can quickly release new features. We're also going to focus on the UI customization so that you can configure it to exactly the way you want. We want to add a few more tools. Of course, we want to add the ability to fuzz, so that right in the form, something will pop up and you can say fuzz this form. It'd be awesome. And we'll hook up to the DOM events and session storage. Yeah, this will be coming soon. In the next 3 months, we're really looking forward to having it ready for release today, but there are just still a few more things that we need to get knocked out. So follow Zap Proxy on Twitter. We'll keep everyone updated with the status of that. And feel free to reach out to me on Twitter or talk to me afterwards if you're interested in contributing at all. If you can write any sort of modern JavaScript, we would love your help. And finally, I think if we look back at this question that we asked our developers, can you test this part of a web application for some broken access control? Hopefully we've reduced that barrier to entry just a little bit. Hopefully by focusing on usable security tooling, we can improve the security of our entire organization. So I just want to give a quick special thanks because I've worked on this project for a really long time. So thank you Segment for supporting me on this. Thank you OWASP for putting on this event. Thank you Bjorn Kimnich and the Jushop team for giving us something to attack. Thanks to the Zap team who worked with me on this. And special thanks to Zem Bennett, the lead developer for the Zap project. His time, his effort, his enthusiasm. When I reached out to him to initially collaborate with him on this issue, he was extremely receptive and really spent a lot of time with me on it. So really encompassing the values of OWASP. And that's all I got. Thanks, guys. Any questions?
Yeah. I like your presentation because I was noticing that everything was real time.
Yeah.
So it's not something you prepared that weeks ago, a month ago. So I appreciate having a real time.
I'm glad you appreciated that. I practiced a lot to make sure that would ideally not fail. Oh, one more. Yeah.
Is there any way to prevent infecting jobs?
So right, there's things like CSP and other things that can help prevent these things from happening. But because we're a proxy right before the browser, we can just strip these things out. And people might be saying like, well, that's funky. But it's fine, right? Because we'll pull them out there, but we'll still be able to analyze the request as it comes in real time. Cool. Thank you, everyone. Thanks, Doug.